In this demo, we'll create a simple rig to pose this robot arm using a single object. In other words, we'll create a goal, and when we move that goal around, the entire hierarchy will rotate. We'll do that using inverse kinematics and the LookAt constraint. Currently, there's a forward kinematic hierarchy in place. We'll get in closer with the mouse wheel and position with the middle mouse and tumble with Alt and middle mouse. At the bottom here is the base. That's the root of the hierarchy. Then there's a turntable object. I'll select that and we'll test the hierarchy. Choose the rotate tool. And in order to know what axes we're actually rotating in, we'll need to use gimbal coordinate system. So from the pull down list for reference coordinate system, choose gimbal. And if we rotate around the Z axis, we can see that the other objects follow. Undo that. And we've got this shoulder object here. And likewise, if I rotate around the X axis, the other objects follow. I'll undo that. For an inverse kinematic chain, in which we can drive the rotations from the position of a goal, we need to introduce some amount of rotation before we add the IK chain. And if we have the object in a straight line like this, then the IK chain will not work properly. I'll select the robot elbow object and just introduce a little bit of rotation in the X axis. It doesn't really matter how much. And now we're ready to add the IK chain. I'll select the shoulder object, go to the animation menu, and choose IK Solver's HI Solver. HI stands for History Independent, which means it's fully interactive and it doesn't care about anything going on in the timeline. Choose HI Solver, and then click on the robot wrist object. And that's the round disc at the end of the elbow. Click on that. And now we see a line joining the pivot point of the shoulder and the wrist. And we can grab the move tool and move the goal around, and we can see that we're able to drive the rotations by changing the position of that goal. I'll undo that with Control Z. The behavior I want is that the elbow and shoulder will only have 1 degree of freedom. And if we move the goal in the Z axis of the world, then it looks fine. But if we move that goal in X or Y, then we don't get the constraint that we want, in which there's only 1 degree of rotational freedom. I'll undo that with Control Z. So to constrain the rotations, we can use the feature of the IK solver, which is the swivel target. We need an external helper object for that. Go to the Create panel, to Helpers, and click on Point, and click anywhere in the perspective view to create that point, and then right-click to exit the tool. Go over to the Modify panel and rename it. Call it IK Swivel Helper. We can make it a little bit easier to see by increasing its size. Set that size to a value of 1 meter. It needs to be precisely above the hierarchy here, with X and Y position values of 0. With the Move tool active, set the X value to 0, the Y value to 0, and it needs to be up pretty high in the scene. Let's give it a Z position value of 10 meters. We can dolly back with Control Alt and middle mouse. And there's our swivel target. Okay, now we'll select the IK chain goal and go to the motion panel. And in that motion panel, if you scroll down a little bit, you'll see IK Solver properties, IK Solver plane, and swivel angle, and pick target. Click on the button that says None, and then select the IK Swivel helper that we created. And once that's done, we can move the goal in any axis, and we'll get the behavior that we want. I'm getting closer there. I can click on the bracket for X and Y position, and now the rotations are only happening in 1 dimension. All right, cool. So I'll undo that. Now that looks good for this part of the hierarchy, but I also want this turntable object to rotate along with the rest of the rig. And to do that, we'll need to adjust the hierarchy, and we'll also need to create an intermediate helper object. Because the LookAt controller does not give us the ability to define which axes are active. The LookAt controller is not quite that sophisticated, but we can work around that by linking this turntable object to a helper and then disabling inheritance of certain rotation channels. Let's create another helper object. Go back to the Create panel and create another point helper. And we can click anywhere to create that. And to make it easier to see, I'll increase its size to 2 meters. And I'll enable the box style display and disable the cross style display. And now it's rendering as a box in the viewport. And let's also change its name. We can go to the Modify panel and we'll call it Turntable LookAt Helper. It needs to be positioned at the pivot point of the turntable. Go and select the 3D Snaps toggle, enable that, and right-click on it, and make sure that we're snapping to pivot points. The default is grid, so let's enable pivot. And with the Move tool, just drag that object over onto the turntable, and it'll snap to the pivot. All right, so that's now accomplished. And now we're ready to link the objects the way that they need to be in this particular rig. I'll select the shoulder. We've still got snaps, so we can turn that back off again. With that shoulder selected, we want to break its link. So click on Unlink. And now we want to restructure the hierarchy here. So we're going to link the turntable LookAt helper to the robot base. So choose the Select and Link tool. Click on the helper and drag to the base. We also want to link the turntable to the helper. So click on the turntable, drag over to the helper. And those links have been made. We can test it. Choose the Select and Move tool and select the base, and everything should follow. That's good. Undo that with Control-Z. Select the helper, and when we move it, only the turntable geometry should follow. And that's correct. So I'll undo that as well. Now, before we add our LookAt, we need to disable inheritance of rotations on the turntable object. Select the turntable, go over to the Hierarchy panel. In the Link Info subpanel, disable inheritance from the parent for the X and Y axes. When the parent rotates in X and Y, nothing will happen. But when the parent rotates in Z, then that rotation will be inherited. So let's test it. Grab the Rotate tool and select the parent, which is the helper object, and rotate in Z, and the turntable geometry follows correctly. Undo that with Control-Z. And when we rotate in X or Y, the helper object rotates, but the turntable geometry does not because its inheritance has been disabled. All right, so I'll undo that rotation. And now we're finally ready to add the LookAt controller. And we got the turntable LookAt helper selected. Go into the Animation menu and choose Constraints, LookAt Constraint, and then click on the IK goal. And notice that the helper object rotated, but the turntable object did not rotate yet. All right, now for the moment of truth, when we select our IK chain goal and change its position, we can see that the rig is working correctly. All right, so we can now animate this by keyframing the position of that IK chain goal. And that's how to create a simple mechanical rig using inverse kinematics and the LookAt constraint.